Assalamu alaikum everyone. I hope you guys are doing great. Well, in this episode, we are going to learn how to measure angles and volumes for paper 3. Okay? Let's talk about angles first. And this is very important for all mechanical type activities. You have this very clear idea that in paper 3 you will be given two questions. Either one question is set on mechanical task or and the second one would be on the electrical task. Perhaps or maybe both the questions are for the mechanical task or both the questions maybe are for the electrical task. So whatever, we are discussing step by step each and every quantity. In my last video, you have studied and you may have learned about the measuring idea of distance and time. Now, today we are going to discuss with angles and volumes. Let's start with the angles first. Angle is a very important element or a physical quantity whenever you are dealing with the forces. Either the forces are acting in a stretch string or a tensionized string, or maybe the forces are represented through a vector diagram. Angles are always there. But in paper 3, when we talk about exclusively angles, the angles are made by the threads, and threads are attached either over a pulley or with some fixed rigid support with the help of a string and a weight attached to it. So, how are we going to measure an angle? But before that, you have to deal with the instrument which is called protector. You can see the two diagrams over here. Both the diagrams, the precision of the protector is different. Again, in paper 3, for any physical quantity being measured, we only check how a candidate is using the instrument and writing the answer in the question paper. The way he represents a value against any physical quantity explain us all about his or her learning throughout the year. And we only check one thing, which is either the answer is in matchable with the precision of a particular measuring device or instrument or not. So here the precision, okay, of protector, this one you can see here. If you just look at the diagram, it's 0 and 10, and you have then further subdivisions you can see. So this one is 1 degree precise, and if you look at over here, 0, 5, 10, 15, 20. So the precision is either 5 degree or 2.5 degree, because I with a naked eye I can even judge the mid position between 0 and 5. So here for this particular protector I can use the half of a least count. Precision is also called the least count, but here if practically you try to witness the midpoint between 0 and the 1, it's gonna be a difficult task. So we cannot take the half of the least count in this type of scale or for this particular instrument. And by the way, in market mostly these are available, and labs it is also most commonly available. So you must remember these logics. Okay, so through protector, whenever you are going to measure an angle and write down a value, you should copy or you should follow the precision of the protector. So two ideas I have just mentioned here, but I am confident that you, if the protector is coming in the exam for upcoming exam series May June 2026, then you will definitely have this style of protector. Okay, mark my words. All right, now Let's take an example directly from a past paper. Okay, now this is May June 2008, paper 31. One situation: a string is passes over two pulleys, and there must be some force attached over here. In the practical, you can just see the details of this question from May June 2008, paper 31, and there is an angle measured between the middle of the strings, and must be there is some load over here. And place one of the 11 identical object in the object holder. This is supposed to be the object holder, and measure an angle theta between the strings as shown, and you can see the two box here. The question is how you will get all the 2 marks for this activity. Let's see what the mark scheme suggested here for this particular part. Apparatus setup without help from the supervisor. Value of angle between 90 to 180, any value, because in this case we are expecting an obtuse angle. And now you can see two more important things in this way here. Although there is nothing mentioned about averaging, but if a candidate measure theta 1, theta 2, and then an average, again averaging, showing an averaging where it is needed or where it is even expected, it's always welcome. But again, you can see theta space, and I need to write an answer. As I just mentioned, protector, most commonly this one is available. You can see the least count 1 degree up now. I don't know why, because perhaps because of a logic, or sorry, because of a mathematical practices. Usually candidates like to write the answer like 1.0 degree. Writing an answer like this way with 1 decimal place, it means you are telling us that the protector given to you has a least count of 0.1 degree. And can you see even a idea with a naked eye of even a 0.5 degree? I don't think so, because in real world, when the angles are being measured, angles are measured with the help of strings, and strings itself have their physical thickness, and usually the strings are opaque. They try to block your vision. So when you put the string or place the protector in front of the string opaqueness might hide 1 degree at least. Or even if they are using a very thin string, that's otherwise. So remember, theta, I have to write an answer, right? You can mention here, you can see here, sorry, like 90 with an SI unit. Again, guys, remember, theta, let's say 30. I don't know why you guys hesitate in making this small circle here. Instead of that, usually students do what? Theta dot. We will detect the mark for giving us an incorrect SI unit. This small circle is a proper SI unit. Please, for God's sake, remember this. So theta 30 degree. So see, we are expecting no decimal place and a proper degree. For this reason, you will definitely get 2 marks here. I hope you understand how the theta must be dealt in a situation. Let's take another example. That's from May June 2009, paper 31, question 2. An angle of tilt of the bottle is the angle it makes with the horizontal when it is about to topple. And most of you must have attempted this question in your routine practice sessions in the labs. Make sure that the lid is secured, tilt the bottle as shown until it about to topple, and try to measure an angle. Now see here. See, they have already mentioned this degree. And that's why I used to call a contradiction, khula tazad. Why not they have mentioned the degree here? Why not? And why they have mentioned the degree here? Again, it's a khula tazad. And for that, remember my words. When they mention a unit, you will not mention the unit with a value. When they do not mention the unit, you will mention the unit with a value. Isn't it sounds like khula tazad or contradiction? But this is the way we used to test the skills, the practical skills of a candidate. Be aware of it. All right, guys, otherwise you will lose a mark. Anyway, so I imagine I measure 45 and the Angle is already there, but I put an angle here because of my practice. So now we consider 45 angle and an angle again. It's just like say like 32 centimeter, and a centimeter is already there. So it's going to be treated as 32 centimeter square, which is an nonsense. Finding a length and writing it cm with cm, it's a nonsense in physics. All right, so avoid the units when they have mentioned the unit. Anyhow, how you exactly going to write this one, because you never know when exactly the bottle will topple. Oh, by the way, in this situation, when the system is in equilibrium, it is mentioned, I remember exactly in this question paper, it was mentioned somewhere, when the system is in equilibrium, try to get the angle value between the threads. So it means if the system is in equilibrium, nothing is moving here. No moving part is there, except when you try to put the protector here, the string will wobble in air. It might give you a little bit difficulty. If it's going to be the question 2, style 2 question, then you can also write it down in the report area as well. Anyhow, we will discuss these uncertainties later on in any in upcoming videos. Okay, so theta, no average working, but the thing, proper unit without decimal place. But here what we are expecting at least 1 or 2 or 3 or 4 or 5 attempts of the theta and take an average. I mentioned at least 3, you can take 4 and 5. Always remember, if you feel a task is difficult to measure, increase your attempts. If you feel a task is easy to measure, just take 1 attempt or hardly 2 attempts. Mark my words. Okay? Take another example. That's from May June 16, paper 31. You have a board attached with a boss and clamp and the rod, and the board is making an angle, some sort of, with the bench surface. The distance between the bottom of the board and the bench should be approximately 15 centimeter, and then measure and record an angle theta as shown in figure 2.2. Here we are expecting the angle between the ground surface and the lower edge of the wooden board. So if you measure theta here, look what the mark scheme suggested, that value of theta to the nearest degree, and the value must be less than 45 because it is an acute angle, expecting to be an acute angle. So theta is supposed to be, again, this is only mentioned here. Tell me, if this setup is arranged in a physical and real world, will the board gonna be slipped so that the angle would change? No, obviously it's clamped. So instantly or apparently the average working is not that important. The thing which is important is the nearest degree value and the trend of an answer, which is supposed to be less than 45. This is just an example. I am quoting it from a past pair question. So remember all these things when you are dealing with an angle. All right, now let's talk about the next physical quantity. In the beginning of the video, I mentioned we were going to cover 2 physical quantities being measured. One, angle. Now the second one, volumes. Measuring volumes. Volumes are measured either with the help of beaker or measuring cylinders, pipettes and burettes. But we are, because I am explaining you physics practical, not the chemistry one, so pipettes and burettes will not be there, but definitely beakers and measuring cylinders will be there. Again, depending on what is the precision level of the measuring cylinders. Usually the measuring cylinders like this one, as if I just expand it, it's gonna be blur. So you can see here between 3 and 4, it's 1 2 3 4 and then 4. So it's 3.2, 3.4, 3.6, 3.8 and then 4. So it means the least count is 0.2 perhaps ml. It is always mentioned on the glassware somewhere, or at the bottom or somewhere at the top, about the precision level of the measuring cylinder. Usually the precision levels are for measuring cylinders are either 0.5 ml, 1 ml. This is 0.2 ml, sometimes 2 ml, and you can easily watch it through the printed values on the glass side. Okay, so now let's talk about if the volume activity is in the paper, how you gonna measure the volume. For instance, October November 16, paper 35, question number 1. In this experiment you will investigate the motion of a bottle in water. Okay, this is about the question, but first of all, you have been provided with a bottle with a mass attached, a measuring cylinder, a jug of water, and a large cylindrical container of water. Use water from the jug and the measuring cylinder to determine the maximum volume of water held by the bottle. Record this volume VF, centimeter cube, value is mentioned for 1 mark, and they have give you a hint that 1 ml is considered 1 cm cube. Now remember, imagine, because you are doing it in a real way, in a real sense, and I'm explaining it right now on the screen, in front of the screen. So if this is a cylinder, a measuring cylinder, you might have a water source, a jug, and this is a tiny cylinder here. What you're gonna do, you will, up to the max level marked here, fill this cylinder from the jug, the amount of water. Let's say record this volume V1 here. Obviously the jug has a larger capacity, cylinder is usually a small one. So empty the first attempt, withdraw this water, or waste it in the bin, in the sink. Then put the water again from the jug, because they are asking you to get the volume of the water in the jug, and you have a cylinder separately provided. So keep filling it, keep filling the water in the cylinder. Take all the portions of the volumes you have measured until the whole jug is emptied in the cylinder, in steps. All right, if you have 4, 5, 6, whatever the steps are, sum up them, give me the answer here. This is how we deal with the volumes. If these volumes are coming in paper 3 physics practicals, then how you gonna measure it? This is the method we are expecting a working here. This is one style of dealing with the volumes, right? Okay, let's see another one. See, this is the answer. Volume VF could be in a range of 260 to 400. Now depending on what volume of the water or liquid is provided in the jug. Examiner knows it, by the way. Who has set this apparatus have already a sort of an idea about the answers, because I first measure the volume and then put that volume of a liquid and then put it in the jug, and let's see how the student will measure it. So I already have the answer of VF. Let's see what candidate give me a value. Now they have mentioned a 1 decimal place. This gives me an idea that 1 ml instead of here it gonna be a 1.0 ml. So the cylinder provided in this case must have a 1 decimal place value, maybe a 0.5 decimal place value or a 0.2 decimal place value. This all depends, and you will definitely have to look through the least count value on the printed scale. So be careful about all these tactics. Let's see another example. May June 9, paper 31, question 2. Use the water supply to measure the volume of a bottle. Again, in this experiment, you will investigate the angle of tilt. So first of all, measure the volume of a container. Volume of a container, you will be provided with the water, or maybe from a source, from a tap, and you will given a container. So that container must be filled up with the water first, like this way. The container, fill it up with the liquid from the source, and now start emptied it in a cylinder step by step. Note down all the breakups of the volumes, sum up and give me the values. Now here additionally something else is mentioned regarding the volume. Justify the number of significant figures you have given for the volume of the bottle. Now guys, this is really important, because here we are expecting, when you are going to write down the answer, let's say 365 centimeter cube, 725.5 centimeter cube, depending on what type of measuring cylinder is given to you. If the least count of that cylinder is 1 ml, this answer is expected. If the least count for that cylinder is 0.1, 0.2 or 0.5, this sort of answer is expected. So how you gonna justify the significant figures you are using? See what the exam Maxim is suggesting. Allow the reference to measuring cylinder in consistent number of significant figures, because this reference must come from the precision of the cylinder give provided. Precision of a cylinder provided. What I have just told you, zero point 0.5 and no decimal place, right? So keep this in mind. Okay, how you are going to justify it, always depending on the precision level for the instrument you are using. So volumes are measured like this way. That it is not much a rocket science. Okay, so and volumes are usually like they are not happening, like the task related to the volume is not frequently happen in the past years, but still it's a part of the course, so you need to know how to measure the volume. All right, so we have covered in this episode two physical quantities: angles and volumes. Any questions, you can leave it in the comments, and meanwhile subscribe and like and share with your friends. Thank you very much. Allah Hafiz.